Good morning, friends. In today's lesson, we'll be looking at two important terms when it comes to atoms. So, we'll first look at atomic numbers, then we'll look at mass numbers. So, let's start with atomic numbers. Atomic number simply refers to the number of protons in an atom. What this simply means is that if an atom has three protons, its atomic number is also equals to 3 because atomic number means the number of protons in an atom. So again, if an atom has, let's say, 20 protons, its atomic number is 20. That is why calcium with 20 protons has atomic number of 20, and lithium with 3 protons has atomic number of 3. So simply put, that's what atomic number is. Now, let me bring another concept here. When we're looking at neutrality of atoms in the previous video, I remember we established that in a neutral atom, the number of protons are always equals to the number of electrons. What this means is that atomic number can also be defined as the number of electrons in a neutral atom. This definition can also be accepted. So it can either refers to as the number of protons in an atom, a general atom, and it can also be referred to as the number of electrons. I have to be careful when you use this term, you have to bring the term neutral atoms because it is only in neutral atoms that you have the number of protons equal to the number of electrons. Let's continue. So we'll move on to the next term, which is mass number. This one. So mass number, what does it mean? Now, when we're looking at the subatomic particles of the atom, we established that the three main subatomic particles are protons, neutrons, then electrons. Now, and I remember we made mention of the fact that the entire mass of the atom, the contribution comes from these two, neutrons and the protons. These two particles are the main contributors towards the mass of the atom. Of course, electrons contribute something, but that contribution is so insignificant. It's very close to zero. That's why its mass is described as being negligible. So sometimes you might even be tempted to assume that the mass contributed by electrons is zero. But of course, not zero, it's just negligible. So the point I'm trying to establish is this. For you to get the mass of an atom, it's always equals to the proton number added to the neutron number. So these two particles added together would give us what we call the mass number. So note, mass number is equals to proton number plus neutron number. This formula is very, very important. In an exams, if you just write, you are asked to define what mass number is, you can just state mass number is equals to proton number plus neutron number. And that answer would score you the full marks required. So just remember that. You can also try and put it in an English format by saying that mass number is the sum of proton number and neutron number. The two definitions mean the same thing. The sum of proton number and neutron number simply means that proton number has been added to neutron number. So they mean the same thing. So that's what mass number is. Now, we'll be solving some examples, but let's me do this. Let's use this symbol to represent the symbol of an element, any element. So we are using X to represent that element. Now, the top of this element, this part, we call it the superscript part, superscript. And this part of the element, you call the subscript. Usually, mass numbers are written as superscript. All right? Whilst atomic numbers, which is the same as proton numbers, are written as subscript. I need you to keep this in mind. So what this simply means is that if I write an atom like this, let's say hydrogen, one with two here, this is a type of hydrogen. The two here represent the mass number, whilst the one here represents the hydrogen's atomic number or its proton number. And if this hydrogen is a neutral hydrogen, it can also represent its number of electrons or electron number. So you need to keep this in mind. So quickly, let's look at how we can apply these concepts: mass number, atomic number, uh, electron number, and all of that to, solve some problems. Now, let's go back to the formula, or let me write that formula again. So mass number is equals to atomic number or proton number plus neutron number. All of us know this formula by now. Now, in an exams, any two of the parameters can be given to you, and you'll be required to look for the third parameter. So, for example, you can be given the atomic number and you can be given the neutron number, and you'll be asked to find the mass number. You can also be given the mass number, the atomic number, and you'll be asked to find the neutron number. Then you could be given the neutron number and the mass number, and you'll be required to find the atomic number. So let's look at an example. Let's take the element hydrogen again. with 2 here and 1 here. This symbol indicates that the mass number is 2. The proton number or the atomic number is 1. So we can use these two parameters to determine the neutron number. So mass number equals to atomic number plus neutron number. All we will do is to substitute the numbers. So mass number is 2 equals to atomic number of 1 plus neutron number. You move the 1 to this side of the equation. So you would have 2 minus 1. That will give us the neutron number. So the neutron number will be equals to 1. As simple as that. Another example, you could be given, for example, helium with 2 here and 4 here. The same thing. So we have mass number of 4, atomic number of 2. So 4 will be equals to the atomic number of 2 plus the neutron number. So we move the 2 to this side, we get 4 minus 2 equals to the neutron number. So neutron number give us 2. So very simple. Let's look at maybe a final example. You could be given an element with proton number of, let's say, 3, neutron number of another 3. Then you could be asked to find the mass number. To find the mass number, you add the proton number to the neutron number. So that will give us what? That will give us the 3 plus 3. That should give us 6. So it's as simple as that. And please remember, in an exams or in a test, you could be just giving any two of the parameters, and you can use simple change of subjects to look for the third parameter. All you do is to substitute the numbers given to you in the formula, and boom, you have your solution to that question. As simple as that. Well, that brings us to the end of today's class. Guys, if you've not already subscribed, like I've always been saying, subscribe to the channel and share with your friends. Those who are struggling, help them out. Share the videos with them so they will be at the same level as yourself. Goodbye and take very good care of yourselves. We'll meet again in the next